Okay, so today we are going to discuss on module 3 that is primarily focused on when we do how do we plan for vSAN cluster as per the customer requirement, kind of what kind of uh, hardware we need to choose, the node size, disk size, capacity and all. Okay, so you must understand how to plan the server hardware, capacity, network configuration, before you going for the vSAN cluster deployment. Okay, like this is more giving you the overview, like how you want to plan and how you want to propose to customer, like how do you need to choose the right candidates. Where I would say right candidates means is right physical server, their storage capacity, primarily cache drive, capacity drive, network component, and actually end of the day how much storage customer will be getting for the utilization purpose. Okay, all right, so well, we'll see the vSAN requirements in detail today itself, understanding the factor for capacity planning and how do we do the vSAN ready node sizing.
Okay, sir.
All right, let me just put it in slideshow mode. So when do we say planning a vSAN cluster? So if I come to you as a customer, okay, so what would be your primary ask to me? Hey, Mr. Customer, tell me what kind of workload you want to put, right? First, first of all, you will do a high level of assessment. Probably you will be having some set of questions with you. Okay, sir, what kind of workload? What are the sites you are planning for? Okay, and what is your application IOPS requirement? On the basis of that, you will pick actually. Okay, pick means like when I say workload type. So workload means you are putting general purpose applications, you are putting some DB, you are putting some VDI workload. Okay. So on the basis of that, then probably you will ask. So even before IOPS, you will ask in today's date, how much capacity you are planning to be available for you, especially for usable purpose, and how much you wants to keep a buffer. Buffer means is say buffer categorized in two way. One is the failover capacity. You are planning for that. And second is you are planning for the future growth. Okay. So these are very fundamental understanding level question that you need to know from your customer before you planning or proposing any vSAN cluster to your customer. Okay. All right. So from hardware perspective, the important things comes in picture. First of all, you will look for the certified compute node. We referred as vSAN ready node as well. So there is a big list of vSAN ready node. If you go VMware compatibility metrics guide and you will select vSAN as a software and you will look up for the hardware, you will get the huge list from the different vendors. There is too many vendors like primarily Dell, HP, Intel, Lenovo, Cisco, all of the major manufacturers, Fujitsu, Hitachi, too many vendors. Okay. Then what we say minimum requirement is recommended from VMware. Each node should carry at least 32 GB of RAM and dedicated 1 GB NIC for hybrid configuration. When we say hybrid configuration, it means that my cache drive will be SSD and my capacity drive will be STD. Okay. But normally, if you'll see nowadays, nobody prefer to go with hybrid because SSD cost is pretty much cheaper as compared to SDD. So better to go for all flash. So when you say all flash, we have to give a 10 GB dedicated network for the vSAN traffic, at least one SSD for cache tier, and at least one SSD or STD for the capacity tier, right? But normally when we make the capacity, people go beyond one, right? How much they can go? 1 to 7, right? But SSD is always 1. Then from compute requirement perspective, where we talk about what kind of hardware we are taking, then the hypervisor for ESX itself, and overhead for the vSAN operations. When we say the vSAN operation, like native vSAN services, or probably in future we are enabling kind of dedupe, kind of compression. So for that, definitely we are requiring some overhead itself. Okay. So just an quick example, like if I would say you took 32 GB as a minimum recommended memory, and out of that you feel 10 GB is required for the hypervisor operations itself, and approximately 4 GB is required. It is just an assumption, right? 4 GB is required for the vSAN overhead purpose, like native vSAN function, dedupe and compression. So dedupe, native vSAN function always have a fixed amount of reservation where we refer as approximately 10%. And this dedupe and compression matters for how many disk groups you have configured per disk group. That will increase in a specific ratio. Okay. So now you will say out of 32 GB, 14 GB goes for system native functions itself. Remaining, I have 18 GB. That's primarily used for allocated to virtual machines. Okay. The same calculation we have to do for the uh, CPU resources as well. Okay. So when you say overhead or resource utilization and all, so what do you feel like? You are working in daily operations everywhere. I mean, where you got crunch most, CPU or memory?
Memories are mostly I've
Yeah,
seen.
you are absolutely right. Out of 10 issues, if there is some resource crunch issue, out of 10, 7 issues would be memory related, right? So because CPU comes in a powerful CPU from the different vendors, and CPU, if from virtualization perspective, CPU have the more capability and more features for, especially from virtualization perspective, right? So if a host, if you can operate 10 or 20 VMs and you are distributing CPU and memory, so as compared to that, CPU distribution happens in pretty efficient way as compared to memory, right? So it's simple example. Like if I would take one core, on the top of one core, you can take ratio 1:4 easily, and you can operate. When I say 1:4, it is P CPU to V CPU, correct? But in memory, typically we take ratio of actual memory to 1.25 or maximum 1.50. It means that if underlying memory I am using at 1 TB, I will not go over provision for 1.25 TB or 1.5 TB because utilization is more, right? So now you can see like either here I can go to 1:5 or maybe 1:6 as well if everything is working fine, right? So memory is more intensive as compared to CPU. So from memory requirement, each host must contain, like we say, 32 GB minimum, at least for vSAN operations, to support maximum 5 disk group and with capacity of 7. So it's again a simple mathematics that we are talking last time also. Each host can carry maximum 5 disk group. Okay. And each disk group, there will be one cache and rest of the, again, 1 to 7. This number is 1 to 7. Minimum 1, maximum 7. So this is my capacity. So it means that total 5 disk group. If I will calculate the capacity drive. This drive size is 35. Okay. So if we'll take in numbers, like for an example, we are taking one disk size is 3 TB, for example. So 7 3s are 21. So I am getting 21 TB raw capacity from each host, and I will multiply 21 by 7. So 7 to the 40. So I am getting approximately 147 TB only from one node, correct? 147 TB approx only from one node, and depends upon number of nodes. Let's, for example, we have made a simple 10 node cluster, then this capacity will go 1470 terabyte. But again, it's a raw capacity. When I am referring as raw capacity, on the top of it, you are going to apply some of storage policy, correct? My understanding is right? You good with that?
Yep.
Okay. Then next is for dedupe and compression service enable. As I said, the dedupe and compression ratio matters for additional overhead, like per disk group. If you are enabling dedupe, it require dedupe and compression together. It requires 30 MB, and only compression, it is required approximately 40 MB additional overhead per disk. So you can see difference here, right? Compression took more overhead as compared to when I do dedupe and compression. Because when you will do dedupe is something, if there is 2 or 3 identical component that are going to store on the underlying storage, it will make just a one component of it and place it here, right? That's how dedupe give you the optimization. Then storage capacity sizing, again, that's all matters key. What is storage required for the VMs? What is the future growth? What is failure to tolerate you wants to take? And the vSAN additional operational head. When I say, see, vSAN operational head is not only limited to CPU and memory. vSAN took some of the storage space itself when it will enable its functionality, kind of vSAN file system, dedupe, compression. So it took additional overhead itself. Okay. So better to, like, if I will do, yeah, I will calculate it manually. Somewhere it is near impossible because there is a lot of factors comes in picture. So for that, vSAN VMware release a vSAN capacity planner or vSAN sizer tool. You can fill their information there and you will get the exact numbers, like as per my requirement. If I am putting, like, for example, customer is looking 500 TB of storage, 100 VMs, kind of all the parameters you can fill over there, and you will get the exact figures, near exact figures for, putting the overall vSAN cluster into customer environment. Okay, so you understand it. Storage requirement, it's the raw requirement, the capacity requirement for VM. Like for an example, customer is saying, overall, I am assuming there would be 5 TB capacity, 500, sorry. Anticipated growth, let us suppose he assume for next 1 year or 2 years, like 10% of that, then 50 TB it will come. Failure to tolerate means how it's designing the vSAN, like if it's designing in n+1. Okay, so it means that like 500 TB I'm getting for 5 node, I require this actual capacity, then plus 1 node. Or if for 1 node I'm getting just, for example, 50 TB, then again 50 TB additional and vSAN operational overhead. Okay, after calculating the whole capacity, reduce the overhead. Okay, then you will get the actual numbers what you are looking for to operate your virtual machines. Okay, we good so far? Sorry for
So,
my dirty
Yes, sir.
handwriting.
No, yes, sir.
Focus my words. Yeah.
Yes, sir. Yes, sir. We are there only.
Yeah.
so this one, like, so for an example, if we have, the 50 TB, sir, that n+1, can you please explain? I'm sorry, I didn't get it.
Yeah, no issues. That is failure tolerance. When I say failure tolerance, it means that, like, for example, we are planning a 5 node cluster. Okay. So in this 5 node, what I'm assuming it, 4 node I will use for actually for the VM and 1 node I will keep for failure. So if any of the 1 node will get failure out of these 5, then rest of the 4 will be okay to maintain the sufficient capacity for your cluster.
Okay.
Yeah. So what I am assuming it, if I am making a 5-node cluster, out of 4, one node equals to 1 node storage capacity, I am considering as at my reserve capacity. If any of the 4 node will get failure, that will be maintained by this additional node. Okay. Or you can say,
Understood.
yeah, equals to the capacity. So this capacity I am reserving. That's a kind of reservation. Whenever any failure will occur, then rest of the storage will be maintained with this +1. Okay, or it's all matter like if customers say I want 2 node failure together, so it will come. Don't worry about it. It all matter on my storage policy. Whatever storage policy we will apply, then according to that we have to plan. Either I have to go for n+1 strategy or n+2 strategy or n+3 also. Okay, so if I'm saying n+1, I'm assuming that I can easily maintain the 1 node failure with the rest of the nodes. If I'm planning n+2, I can easily maintain. If 2 nodes got failure, is still my original node have the capacity for maintaining this failure. If I'm planning for n+3 again, my remaining nodes have enough capacity to maintain the storage if in case all these 3 nodes got failure simultaneously. Okay.
Okay, sir. Got
Sir,
Alright.
in if n+1, for example, if 2 nodes, okay, in worst
Uh-huh.
situation goes means
See, yeah,
the data will be corrupted, how we can retrieve the data?
not actually. I'll let you know. For actually, there is some requirement. That's I told you. It all depend upon your storage policy, how you
Oh,
design the storage policy.
okay.
And if in case a high level example, if I am planning RAID 1, so RAID 1 will say you required recommendation is 3 node. Okay. Why
Okay.
they given 3 node? Because if they will use 3 nodes, if I am writing the original data, it will come here, and 1 node will be reserved. So in this case, I could say 2 + 1, and this is the n+1 architecture.
Okay.
Okay. So out of it, it will get failure. It will be here. Each kind of policy, So capacity for the VM, especially when you create the VMs. So VM create primary these objects. Okay. VM home.
I think we are losing Kuldeep, sir. Can you hear him?
No,
No,
no.
no. Now
Sir,
you,
sir, we lost you, sir. When, sir, your audio is we lost, sir, sometime back.
yeah. Is it fine now?
Yeah, yeah, it's fine now.
I was on a pause actually, don't worry. So
Oh,
what I was saying is my
okay.
pointing device is not working properly. That's why I was on.
Oh, okay, okay.
So VM home namespace. When we say VM home namespace, it is primary your VM folder, right? You know, each VM creates a folder with its name, right?
Yes, sir.
VMDK are my disks, virtual disks. Snapshot, again my delta disks that is used for a snapshot. And swap object is my swap file that is created by the virtual machine. But swap file is again the temporary. It's not the mandatory one. Swap only when some memory overheads come. You know very well, right? So the snap objects primarily inherit the storage policy setting from the base VMDK file. When I say base VMDK file, for example, if I have applied some policy here like failure to tolerate RAID 1, it means that same policy will be applied to this delta disk. Swap object inherit the storage policy from VM home namespace object. Okay, what it means? If any swap file got created by default, swap file placement holder itself, like this is my VM folder. Okay, so this is my VM name object folder. So whatever the swap object will create, like for example, templates create 100 MB or maybe 200 MB. So it will it will follow the same policy that is being applied to your home name folder. Okay. So now you could ask me, sir, you are showcasing us 3-4 type of object. Can we have different set of policy for all these? Answer is absolutely yes. For these VM home folder, we can have separate set of policy, and for these we can have the separate set of policy. That's technically possible, but people don't use, actually those who don't know too much, so they keep as in a common storage policy. So from where people wants to see the storage efficiency, okay, they don't the workload is not more kind of I would say IOPS intensive. They keep the kind of storage optimization policy, kind of FTT2 RAID 5 or RAID 6, kind of that, and rest where they are not looking, they are looking storage performance and all, they keep as FTT1 RAID 1. So altogether, see, this slide is telling you my snapshot will leverage the same policy, that is for disk. My swap will leverage the same policy. Okay. Now what I am trying to telling you here is, sir, for these all objects, can we use different set of policy? Answer is yes, we can. Storage policy we are going to discuss a lot in details. Don't worry about that. How it's apply, what is the way and all. Just for an example, if high level, if for these object I want to apply the RAID 1, I can apply. For these two objects together, if I want to apply RAID 5, I can apply, or vice versa, or common policy. It's all matter like how you are planning. Okay. Again,
Okay, sir.
still if I have the different disk, for example, I have disk 1 where I have installed my operating system. I have disk 2 where I have just installed my application data. Now customers say, hey, Mr. Service Provider, can you just put my disk 2 in where I get the faster IOPS or faster in and data read and write mechanism? Do you have some policy for that? I would say yes. Can you put the disk operating system only with the disk? I don't want from operating system performance and all. Just I want some storage optimization. Can I put separate policy? Absolutely yes, you can go. So policy level is pretty much granular here. You can go. But during the planning size, we cannot go in too much deeper side. We just consider high level. When I say high level, like what is your VM's capacity? When you will ask to me as a customer, hey, Mr. Customer, on an high level, what is your capacity requirement? Just tell us. Later on, we will do granularity and all. I'll say in high level, today I am looking for 1 petabyte of data and I'm just expecting 10 to 20% growth near in uh, like 1 year, 2 year or 3 year plan. Do me the sizing accordingly. Okay. All right. So planning, like we were talking about in previous slide itself, failure to tolerate, what is going to be your FTT policy? So like on, again, it's in high level. Like if customers say, sir, I have this 1024 terabyte of data, just plan a storage, and I just want to keep overall RAID 1 with failure to tolerate 1. So it means that you will assume like definitely are in RAID 1, I'm getting to get 50% of storage. Okay. So out of 50% of storage, somewhere I have to plan the raw capacity 2048 TB, because RAID 1 itself giving me the 50% of use it. Correct? Agree?
Yes, sir. Yeah.
Especially for the VMs. Beside that, beside on the top of it, you will factor how much overhead. Like for an example, my I'm just assuming overall 15% overhead. So 15% of it, how much it will go? 203. Approximately, I would say to 300. Correct? So somewhere you will give to customer 2400 of TP. Again, this is just an high level number. So this is, I just assume the actual capacity. Okay, and on the top of it, I have assumed vSAN overhead, like for policy perspective, dedupe compression 50%, 15%, and I'm going approximate number 2400 TB. Okay. But if customers say like, I want the RAID 5 or RAID 6. So within RAID 5 or RAID 6, you will get more storage efficiency, because straightforward, when you plan RAID 1, you have to plan double of space. Okay. But in eraser coding, it will consume 33% more additional space from yours. So it means that if a customer is looking approximately this amount of TB of data to be capacity, so you just take plus 33% if you are planning FTT1 RAID 5. So it means that it go near about this, right? And plus add the ratio same way on the top of it, like 10 or 50% of that. I believe I have already considered it. Okay. So that's the way you have to plan. So here it is just showing you the high level numbers so that we should not have any confusion when we are planning some storage policy. It is planning is on paper, right? Something you are going to do on ground, what you need to think. Like if you take RAID 0, FTT 0, minimum node 1 is enough. Recommended is 2, just to maintain the failover. If you are planning RAID 1, FTT 1, minimum node requirement is 3, but recommended is 4. If you are planning RAID 1, FTT 2. Okay, so what is this word FTT? Failure to tolerate. It means that how many concurrent failure you can maintain. That's the meaning of FTT. Okay. So if I would say FTT1, RAID 1, it means that I am planning something I can tolerate one node failure. Okay. So for that, what VMware is telling you, minimum to minimum, you need 3 nodes, and the recommendation is 4. Why recommendation is 4? Reason is being, whenever we will write some data as per this policy, it will go original copy, mirror copy, witness. This is just a witness, just kind of quorum. And this is plus 1 host. It means that if any of that get crashed, still my data is safe, but in warning stage, because there is no redundancy maintained now. So what it will do on the 4th node, it will again recreate the redundancy of this one. That's what. Again, for storage policy, we have the entire chapter. Just understand it on high level. Okay, so that I'm trying to tell you, like, what is the meaning of FTT here. FTT2 means is we are maintaining 2 node failure parallelly. We required minimum 5 node, recommended 6. Again, RAID 1 with FTT3. We are planning for 3 nodes simultaneously failure, but people actually don't go with it because a lot of capacity loss. RAID 5 or RAID 6. Okay. So these are the different set of policies we can apply. And on the basis of that, we can do a row calculation, just a high level of calculation on the basis of customers' capacity requirement. So do you need to do the manual calculation in Node? That's what I told you in very beginning. No, you don't. But yeah, you can do some mathematics. That's fine. But VMware are given a good calculator for that. You can go ahead and just put the value and you will get the actual capacity on that. Okay. We good so far?
Yes, sir.
Yes, sir.
vSAN reserve capacity. So reserve capacity is again for your capacity that you are planning for for maintaining the failover. That is my reserve capacity. That's what it. Okay. So previously known as slack space. Slack is something free space I am putting. I'm just maintaining a free space for in case any of the node got failure, the storage can be rebuilt on another free node. Underline storage. Okay. So reserve storage capacity is dynamic. It's dynamic internal operations and host rebuilding purpose. Okay. For example, today you have a For example, 5 node cluster, you put in maintenance mode. Okay. So for the maintenance mode, it means that this capacity is not available at all. Whatever capacity is being given. Okay. So that will be maintained by this one. Or maybe you got crash this node by XYZ region, storage failure, something like that. So the sufficient node can rebuild the missed storage. For that purpose, we are using this reserve capacity. Okay. Again, it matters. It is pretty much correlated to the previous slide where we were talking about FTT1. Okay. So this reserve capacity is defining on the basis of policy that we say. So earlier we say we keep we keep 40, 25 to 30% as in by fixed slack storage. But from vSAN 7 perspective, they have made it as a dynamic. Dynamic means is if I would reserve 25%, this formula is pretty much fit when we are configuring a 4-node vSAN cluster. Out of 4 node, we are saying, yeah, just keep 1 node capacity. It's not 1 node means 1 node equals to 1 node capacity. Keep at reserve so that if any of the node got failure, still we have the capacity equals to 1 node. I can easily rebuild the components, right? So it's a pretty much fit formula when I say 25%. But again, if I'll take this example, 1, 2, 3, 4, 5, 6 nodes. Now I am saying keep 25% reserve. And I just want to maintain 1 node failure. It's not a right formula, right? Simple. Just consider these 6 node as my 100% node. Out of that, 1 node capacity. How much it will go? You just divide 100 by 6. Approximately 18%, right? If you just consider these 6 node capacity equals to 100%. Okay. Divide by this. How much it will come? Approximately 16.6.
16.6, yes, sir.
Right? So automatically, this slack space will be now 16.6%. Again, if I'll increase it more, this value will divide by 7 and it will be reduced.
So
Approximately
based
14.
on the node increasing, the
Absolutely.
space
Slack
may
space will reduce.
relaxation space we have.
Slack space will automatically reduce. I mean that your reserved capacity will be automatically reduced. But again, to implementing this reserve capacity formula, that's what they said is you require at least bare minimum 4 nodes. Okay.
Sir, is this a function in vSAN we do it or it
Yeah,
automatically does it?
automatically it pick. But if you want to fix this value, you can do that.
Okay.
Especially it will come under the capacity reservation part. That's an option available within vSAN. We'll see definitely. Okay. Then designing the vSAN network. So again, the vSAN network, what kind of switch we are using, what NIC teaming and all. So again, distributed V switch. Again, it's not mandatory. You can go with the standard switch also. But if nowadays you will see distributed switches in very much in trend, then NIC teaming and failure, where we say NIC teaming and failure policy. We would say, if I would take an example here, if we have a cluster where we are primarily leveraging only 2 NICs, okay, 2 10 GB NICs or something like that, okay. So if I will make my vSAN network here, vSAN as an VM kernel network, so definitely it will go like that way. But for that, let's take another example. Management, we have another traffic management, vMotion, virtual machine, vSAN, okay. So this is 10 GB. So I would dedicate 1 NIC. Like for these 3 VMs, my NIC 1 will be active for all these 3. Okay. Different port groups. NIC 1 will be active and NIC 2 will be standby. Wherefore, especially for vSAN, what I'll do, NIC 2 will be active. Okay. NIC 2 will be active and NIC 1 as an standby. So what is the meaning here is just align a dedicated network for your vSAN traffic, but it's because it generates a lot of traffic. Okay. Then we do apply network IO control itself. Network IO controls primarily we use where we are using the shared way. When I say shared way, for all these rest of traffic, I have make nick teaming policy. You are aware with nick teaming, right? Active, active.
Yes, sir.
And
In server level, it means the same. Two
yeah,
nodes,
yeah. That's
passive and
in,
active.
yeah. And in for vSAN also, you have done nick teaming policy active, active. So it means that overall my workload is sharing. Here also both the nicks being using, here also both the nicks being using. So in that case, yeah, because my recommendation is for all flash array, there should be 10 GB, correct? So I assumed NIC 1, NIC 2, each of 10 GB. So how much bandwidth pool now I have? 20 GB, where VMware is recommending 10 GB recommended for the vSAN traffic. But now this 20 GB as a shared bandwidth. Why I'm saying sharing? Why I'm saying shared bandwidth? Because I have given active, 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 active. So in that case, NIOC comes in picture. Network input output control. Out of total bandwidth, what you will define? 50% allot to vSAN. If you will allot out of this 50%, it means that automatically you are going to get 10 GB. Okay. Then probably you can divide it 25%, 25% like that. When you say 25, 25, 25, it doesn't mean that from the rest of bandwidth, like out of 10 GB, it will divide 25, 25% for rest of the traffics. Okay. Then we good, Bhanu?
Yeah, I was about to ask, like, so to understand it, like, we have two NICs, 10 GB, and then we would, what we'll do is that we'll assign, if we are assigning active, we can utilize NOIC
Absolutely.
to specifically utilize
Giving the
the network
dedicated
bandwidth.
bandwidth. Yeah, reserved
Okay.
bandwidth to my next. Okay. And from the
Okay.
rest of the available bandwidth, I will share that bandwidth for rest of the traffics.
That is one way, sir. That like
Yeah.
network IO control, and the other way is we simply just do active standby.
Absolutely right. Like,
Okay, got it.
okay. Or I mean, it's all matters like how the design being happen. Sometimes you will see each host have 4 NICs. So in this 4 NIC configuration, what we say, align your the primary one just for the hypervisor management function, kind of management, vMotion, kind of that. And these two again divide between VM traffic and vSAN traffic. And again apply the active standby formula.
Okay, got it.
Yeah. Then jumbo frames. So jumbo frames, what is the meaning of jumbo frame? So end of the day, this host is somewhere connected to the underlying network, correct? Your underlay network. And my traffic is passing out through these network switches, correct? And for passing the traffic is being generated by this port. Definitely it will come to this network switch. Then it will go to next host. Correct, Sarwan? Am I right? The
Yes,
same
sir.
way it will go to next
Yeah.
host. Okay. So by default, my frame size. So frame is the layer 2 packet. If you will go a little bit back on TCP/IP layer or OSI layer, there is a frame is a term, right? So in frame size 1500 is my MTU, maximum transmission unit. It means that logically a frame is a unit to take your data chunk, that is 1500 byte one time. Okay. So it means that whatever traffic is going in the chunks here, a single frame is 1500 bytes. Okay. But if you'll see, my network is pretty much latest, strength one and all. I want to make it faster. Let's make it faster. Like, don't depend on 15. So how the jumbo frame is defined? Jumbo frame will say, you just make this frame size bigger as compared to the default. So you can make this value up to 6 times of it, 9,000.
Yeah, sir. We have
Yeah?
we have 9,000 also MTU
Yeah,
values.
correct. Sorry, 9,000. I'm very sorry. I have written 9,000, but speak 6,000. 9,000.
9,000. Yes, sir.
So it means that now my frame size is 9,000. So 9,000 frame sizes means that my speed, I'm getting the performance 6 times faster over my data travel speed across the uh, devices, networks, and all. Okay, so in that case, especially for vSAN traffic, we can enable jumbo frame as well. When we say jumbo frame, it means that I am increasing the MTU value. This MTU value should be configured on these network ports because the default value is 1500. We should communicate to our network engineer. Hey, Mr. Network Engineer, my ESXi ports are coming here, and we are consuming 48 ports from each switch. Please enable jumbo frame at your end, but also we have to enable at our end, right? So somewhere my traffic is coming from D switch or standard switch. So on D switch level, I mean distributed switch level, in advanced configuration, we will increase it. Okay, so it's mandatory. We have to enable jumbo frame on both the end. But if we'll enable only D switch and here, you will get some problem. Either your host will not discover another host. If it's a mismatch of frame size, then oftenly you will see the vSAN, one vSAN node is not available. I'm able to finding another node. Okay, so jumbo frame somewhere makes our environment faster, my transmission speed faster. So we can enable, that's not a problem. If my environment is supported, that's fine.
But sir, we should uniformly maintain that, sir. So if we give one host for 1500,
Absolutely, that's what I'm saying. Yeah.
Okay.
On each host, you have to enable on your network device, ports everywhere. Otherwise, one host will not able to find the another host itself.
And that value also uniform, sir, right? 9,000 in we have
Correct.
configured 9,000.
Correct. If
All
it,
hosts should be in that 9,000 only jumbo frame.
yeah, right. RDMA is again your network type where we say your are a dedicated NIC that you are getting the equivalent performance of a physical NIC. So all these factors. So normally people don't go, but yeah, these are the pretty much common term from 1, 2, 3, 4. RDMA is nothing, just a network interface card that will be mapped directly to your PCI adapter and you will getting the equivalent performance. But when we do active standby, that's a similar kind of configuration. If I have made one dedicated NIC active for vSAN, then that's fine. Okay, we clear?
Yes, sir. Yeah.
Yeah. So this is the main thing. So just not think of, yeah, I have to go and I have to make a, don't consider yourself limited to a vSAN engineer or a deployment engineer. Consider from the mind of perspective, you are end to end. I have to design the solution. I have to implement the solution, right? So these all things pretty much good when you are planning and designing the vSAN environment. Okay. So this is my vSAN ready node sizer. That's why I told you in beginning, you don't need to do too much mathematics manually. Go there, fill your values, and just do some calculations. Okay. I'll just show you. Don't worry about it. So the output would be like that. You have to here, like you could see in this picture, a vSAN cluster configuration it took. Like you have taken 6 ESXi host. What would be your usable capacity? What is the vSAN version you are going to use? What is the operation reserve? Okay. What is the license you are going to apply? Okay. Advanced or enterprise. So vSAN comes in a different flavors. Probably you are aware advanced and enterprise. Within enterprise, we are getting some enhanced features kind of vSAN stretch cluster, that kind of stuff you will get only with the enterprise edition. So this is my vSAN compatibility guide. When we say vSAN compatibility guide, so you will search for the vSAN ready node and you will find a big list of vendors itself. Like you want to see for different providers, it could be Lenovo, it could be HP and all. Just select it and you will, on right side, you will get all the details of the providers, kind of your, again, HP, Dell, Lenovo and all. So here is a quick demonstration for vSAN ready node. And then yeah, review the requirement and all. That's what we have done. So let me just quickly walk through with the vSAN sizer, है ना? So you can simply search Google. Let me do. Now we have to go to Mr. Google and ask for the vSAN sizer, huh? vSAN ready node sizer. You will get many, but the most prominent one, the one you will use from VMware. vSAN ready node sizer. Okay, vSANsizer.com.
Oh, we have a separate website only.
Yeah, Shravan, saying something?
Oh, we have a separate website also for vSAN sizer.
Yes, yes.
Good.
So here maybe sometime it will ask you the login. So you just
Okay.
provide your VMware credential. So here you
Okay.
could see the, we'll go with the old standard architecture now. And yeah, quick sizer, configuration type. You are saying we are going to take all flash. Which vSAN version? It will give you the listed. So
Okay.
let's plan for update A1 itself. This is the vSAN ready node profile where you want to go all flash AF4, AF6 or AF. So this is the vendor. So let us suppose choose a vendor. So these are the list of certified vendors. Go to Dell for now. And
Okay.
Dell doesn't mean that it will give you one. There is a lot of a big list from Dell itself. Okay. So all are the certified servers. So let's take here
Or it's R7640. Okay,
760.
760.
Yeah. So these are the number of servers you are planning. So let us plan for 4 node. And here you are saying the number of disk group we are planning per node. How many? Let's make 2. And capacity drive per disk group. It means that per node you are getting 14 disks. Okay. And capacity drive size. So automatically when you will select the ready node here, it will tell you the recommended one, the supported one. Let us suppose take 1.6 here. This is my FTT policy, FTT1 RAID 1 or FTT1 RAID 5. You could not see RAID 6 here because for RAID 6 we required minimum 6 node. So let's plan for RAID 1 for now. Do you want to enable some of the features? Don't enable it for now. Let's make it as a vanilla one.
Okay.
Okay. Or later on you can enable. That's not a problem. Okay. So let's do some calculation. What it will show you.
This is good, sir. We were giving everything options with predefined one,
Yeah.
like
Right.
compatibility matrix and all. This one I was not aware. But in my team, my colleagues used to say we have ready node vSAN, but after seeing this only, I got some idea.
Too many. Yeah.
Yes, sir.
So it's too many providers. You can download your reports also. Ready node profile. We have select all number of servers for this group. This. That is fine. Okay. I believe calculation. Oh, here checksum overhead. Usable capacity will be getting 38 TB. Operation overhead space 9. Disk formatting overhead this and file system overhead. And this is your effective capacity end of the day. 38 TB, right? With the RAID 1. But let us see if I'll make it RAID 5, will there be any impact? So what is my effective capacity now? Usable one, 38 TB, correct?
380 so yes.
Yeah. So if we'll do a raw calculation, how much we have taken? 1.6, correct? And I just want to see what is my effective end of the day if I'll do. So we have said 1.6 one capacity drive size and we are taking 7.2. I mean then per node we are taking
14 into
14.
1.6.
14 into 1.6 into how many nodes we have taken?
4.
4 nodes. So total 90 है ना? Approximately we got 90 TB, but
Yes.
out of 90 TB we got approximately 40 TB usable. Okay, because why? Ideally it should be 45, है ना? But 5 TB is somewhere some overhead, है ना? Because it's take operation space also, file system overhead, and let us see within this calculation if we will put some
So we have not
deduplication.
enabled deduplication compression. So if you enable also, it will
Yeah,
yeah.
it is telling you
Yes.
it's going per disk group 1.5 and
Yeah.
definitely it will be reduced. So now, yeah, but now you will say, sir, why it's not reduced? Because when you will apply dedupe and compression, it have an ratio 20 to 25% you are getting advantage too. Definitely when you will do dedupe and compression, you will get space optimization, na? Correct?
Correct. Yes, sir.
And
Yes,
out
sir.
of that, it will reduce some of the amount for the operation purpose. So now you are getting the operational capacity approximately 57%. Okay.
Yeah, it was earlier 1.6, but we enabled the deduplication. It came to 1.5
Yeah,
below the
but along
calculation.
with it, it also consumes some of dedupe overhead.
Overhead. Okay.
Yeah. So it's a magic. I mean, you don't need to go here and there and just do some rough calculation and just give this to customer.
Okay.
But yeah, that is fine, calculation and all. But it's matter. Like if you will go here, it's good. I am doing some capacity and all, that is fine. But when you do plan overall sizing, it's not matter ki you will only plan for capacity. Okay, you have to see CPU, memory, and all. है ना? Remember, so capacity wise it's fine, but you will somewhere you have to coordinate with vendor also. Hey, Mr. Vendor, yeah, I require this CPU configuration because within within one node type, you will get a lot of CPU options. You will get a lot of memory options as well. Okay, and for that, what was my tab? Was that vSAN? Definitely, vendor will be helping you a lot when you are going with Dell or HP. They will tell like. With this particular configuration, you will get this amount of CPU, this amount of RAM. Because to operate certain things, these operations and all, this all matters like what is my standard size from CPU perspective, capacity perspective. Right? Now I have opened the vSAN compatibility matrix here. Okay. So if I'll choose for my vSAN 8, so these are my providers. Let's take Dell again. So these are the generation, CPU generation, right? These all are my, these, if I'll select it and these are my series, like if I'll choose HY, so these are all CPU generation. And again, within Dell, it's not only key if you will provide, if you will select Dell vendors, so Dell Blade, Den server, Rack server, lot of another server family that will support, right? So do you want all NVMe? Like for example, you are planning for some capacity from here, like raw storage capacity somewhere 96 TB you are looking for. Okay. So what it will show? It will show only the it should show you only the compatible one. One moment now. Yes, that's right. That's right. For generation, we'll say the Xeon. search your search for vSAN. We did not recommend back to okay. So with this configuration, what it is saying, it should show me some recommendations actually. When we'll apply the filter, it should show us some recommended one, like, or I think here it is giving, like, if I'll do select Dell, within this version, these are the capacity that we can select, and these are the disk type we can select. Okay, so this is just, I mean, not factor it as a complete calculator. It is just telling you the compatibility perspective. Okay, so if tomorrow you will say, sir, can I apply Fujitsu, can I apply Hitachi? Yes, answer is yes. Within Hitachi you will get all these series, it is showing you. Okay, and like from here, if you will select, so it will automatically filter the list, and it will automatically remove the nodes which are not supported with hybrid. But yeah, it's I mean, it's simple way, like if there is something on hybrid, that will support to all flash, or if it's a all flash, it support to hybrid as well. So from here you can check if I am selecting some of the vendors to deploy the solution for all vendors are available in the market, and how I can deploy. Definitely vendors is going to help you a lot in this case, especially for selection, CPU, memory and all. And one more thing, if you especially wants to go for kind of VxRail, okay, so does VxRail in the list? No, because these are the standard vSAN ready node. VxRail itself have its own separate calculator. Reason is being, VxRail use some of more capacity overhead for its all management VMs, right? So let me just walk through quickly. If I will say VxRail sizer, but that is more granular, because in VxRail you are going with particular vendor. That is my Dell EMC, okay, and only within that choice you can select for the you can select the hardware from the Dell EMC provider itself. So again, I think it's asking for me logging. Somewhere you require a partner account actually to use this sizer tool, but that is going to show you more magic. It will it will allow you to choose the CPU family, memory family, everything. So let's start it's some agreement. Yeah.
Sir, I have one doubt. So for
Yes, yes.
VxRail, it is by default we have to use vSAN plus data store, or we can go with the VMF with data store.
Actually, what happens if we'll compare with the native vSAN ready node? In vSAN ready node, you have to create vSAN cluster manually. Okay. First,
Okay.
you will install ESXi, prepare for vSAN, then deploy the vSAN cluster. Okay. But here, all the preparedness will done before deploy the cluster, and during the deployment of VxRail cluster, it will take care of all this stuff. Your host build, your vSAN build, policy and all. So if I'll select greenfield here, let us say new use case is kind of, especially it's giving you again accordingly to the recommendation. Like for you are going for DB, general purpose, whatever your project is, click OK.
So can you explain the purpose for a greenfield and the terminology
Greenfield is
we
the
are
new
using?
project where we are saying
Okay.
we are
Okay.
deploying as a fresh installation. Okay.
Okay. Okay.
Or if some customer is planning for transformation kind of that, we say refer as brownfield. Let
Oh,
us suppose we are taking the native VxRail, click OK. Is the version, okay, VxRail version 8 is means that is supported with vSAN. We'll say for now original storage architecture. ESL talk later, don't worry about it. So here, now you will say it will definitely keep some of the management VM. Here you will select the VMs. You are saying workload, number of VM. Let us suppose today you are planning for to put your 200 VMs. Okay. IOPS per VM, IOPS percentage. It's not mandated to give it, still that is fine. Usable storage per VM. Suppose that you are planning for 300 GB storage should be available. vCPU per VM you are planning 4 and vCPU per physical core 4. Specific for megahertz, that's fine. Memory use per VM. You are saying, I'm assuming 16 GB active memory. Out of this 16 GB, you are saying, sir, every time at least my 50% of memory will be active. Okay.
Sir,
So,
but depends, sir. We have many. So, for example, we have DB VMs or VDI VMs. We can't calculate it, sir. Sometimes it will take peak hours will take more memory.
yeah,
Non-peak hours will take
yeah,
less
yeah. For
memory.
that, we should factor as average
Okay.
of that. Okay. So either you can add another category of VMs here. Okay. It will mix and merge. Let's take one type for now and start sizing. When generation. All right. So these are my 16G, 15G. These are my VxRail appliance generation. The latest one is this. Within this, you will find all these models from Dell EMC VxRail, and just click on start IOPS. IOPS also we have to give. IOPS, what we are assuming is, let's assume 200 IOPS. IOPS means storage IOPS per second. Start sizing. So it will give the best recommendation to you, how many node, capacity and all you need to go. Okay, so what it is saying, for this configuration, you have to make V series 660 10 node cluster. Okay, what all you will be getting here? You will be getting, when I say one node, it means that a one single socket physical with 32 cores, with 32 core, 10 node with 10 cores. The total calculation will come here. This is memory. How it's considering the memory? It's considering 16 GB, 16 GB of memory, then 160 GB you are getting. No, sorry, 16 GB per node. Per node means is 2 per socket, it is giving 16 GB. Okay, if you will multiply by finally your memory is 512 GB you are getting here, and if you will maximize it, it will go up to 5 TB. TIB just a bit unit of higher. And here also you can see what is my ratio. It is saying you 2 nodes means 2 disk group per node, total 20. Then it is saying you the capacity one. For cache purpose, it's take because it's making that 2 disk group. That's why 10 nodes. So it will make total 20 disk group. It is taking 8 capacity. Then for 10 nodes, I mean, when I say 8, it means that per disk group, 4 disk it's giving to give total 8, then total 2 disk group. That's what it's saying the 80. It means that per disk group, you are going to utilize 4 disk. Total is 8. Each node is going to create 2 disk group. Okay. It will consume 4, 1, then 8, 8, 10, 80. In 20 disk group, totally it will consume the 80 disk. Okay. So as per the calculator, it's gave you the best recommended value. But if you want some customization in it, you can do that yourself also. How? Like for an example, sir, I want these gigahertz to be faster. Okay. But all these are pretty much dependent component, and it will only supported configuration. Let us suppose you are saying, sir, I am looking for the higher process. Okay. Click here and choose the process which you are looking for the faster one. Okay. So this is the available list. With this available list, you can go up to 2.6 gigahertz. Within 2.6 gigahertz, it is again looking the best fit configuration. And if this configuration will not be supported for this, it will let you know this is not a supported configuration. You should choose another set of RAM, CPU, and host configuration. Okay. Now, wherever you are looking arrow, you can make a change. Now, can you see it is a change now? Yes. Earlier, how much was there? 32, I believe. Now it is 24 core. Right. So you can amend as per your requirement, and you can coordinate with vendors also. And it is just an high level. It is showing you what, how much CPU you are getting with this configuration, this much, and this much amount of free, 18% will be free, and your 6% is your access beyond free. In memory, as per your workload, this is the usable one, and this is the free one, and this is the access. Raw storage, you must getting this, but from usable perspective, you are getting this amount of storage. Now, if you will say, sir, this chart is good, can I see something in details? Yes, you can import this report, and you can see each parameters in detail, what actually being calculated by this calculator. Still, if you have choice, sir, I don't want to go with VE660 node. I am looking for some another type of node. Okay. You should be able to change that also. Just let me see. Because by default, say hybrid, you can go for all flash as well. Okay, so this we can discuss too much offline, and if you just play around it, you will get to know this is what calculation. And to fine tune it, definitely you need to coordinate with the respective Dell EMC counter team, and you will get the optimized environment and optimal, because it's all matter. Every time you will not do the same calculation for DB cluster, same calculation for VDI, same calculation for general purpose. Definitely you will give some priority on the basis of your workload type. Correct? Maybe for VDI, you will not get too much heavy configuration, and you will not propose to customer too heavy configuration, because you don't want to spend too much money, because in VDI, my consumption is not pretty much high as compared if I will do the high ops DB kind of thing, exchange server and all. Got it? But when you will play, you will learn a lot around it. But yeah, it gives you a lot of insights itself, especially in case when you are planning the Dell EMC VxRail. But again, I would say if you are planning for vSAN ready node, don't use it. Only when you are planning to sizing something on Dell EMC VxRail, then only use this calculator. If you are planning just a simple vSAN ready node architecture, then do this calculation. Okay. So it's all matter about the environment and requirement. All right, guys, we good so far?
Yes, sir.
Okay, so for now, I'm going to stop the recording. We'll take a quick 5-minute break, grab some water. Then this next module will be talking about the deployment section. Okay.
Okay, sir. Yeah.
Sure, sir. Okay.